Good day, greetings. Welcome to another video. So today's focus is Euclidean geometry. So the question goes as follows. It says in the diagram below, PQRS is a rhombus, and they say that we need to calculate the size of angles X, Y, and Z. So given the size of this angle here to be 33 degrees, and we are asked to find the size of X, Y, and Z. So to find the size of X, we need to recall the properties of a rhombus. Firstly, we can discuss the properties of the diagonals of a rhombus. So these are the diagonals, and some important properties of the diagonals is they bisect each other. They bisect each other perpendicularly at 90 degrees. And the other aspect is that, or the other property is that the diagonals bisect the angles equally. So if this is the full composite angle, the diagonals split the composite angle equally. So if this is 33, it means the size of X should also be 33. So to write this down algebraically, we can say that angle X should be equals to 33 degrees, and the reason is diagonals of a rhombus bisects interior angles. So let's find the size of Y. To find the size of Y, you need to recall the properties of the sides of a rhombus. The properties are that the sides of the opposite sides of a rhombus are parallel. Opposite sides of a rhombus are parallel, and all four sides are equal in length. And because we have parallel sides, we can form a Z shape, and these parallel sides exist between parallel lines. It implies that we're dealing with a pair of alternate angles. So we can say that angle Y is equals to angle X, which is equals to 33 degrees, and this is because of alternate angles. This is true because PQ is parallel to SR. And lastly, we need to find the size of Z. If one were to consider PRQ as a triangle, and we need to also acknowledge that sides are equal. This is possible because for a rhombus, all sides are equal, and because triangle PQR is a isosceles triangle, and we know for an isosceles triangle that angles across equal sides are equal. So this angle here is across this equal side, and this angle here is across this equal side. So if this is Z, it means that this should also be Z. And we have this composite angle here to be 66 degrees because it's 33 plus 33. So now we can use sum of interior angles of a triangle. We can say Z plus 66 degrees is equals to 180 degrees. This is because sum of interior angles of triangle. So this simplifies to 2Z plus 66 degrees is equals to 180 degrees. Therefore 2Z should equals to 180 degrees minus 66 degrees. This is equals to 114 degrees. Therefore angle Z should be equals to 114 degrees divided by 2, and this gives us 57 degrees. Thank you so much for watching. See you in the next one.